Take an overview now about the Test Universe software. As you can see, here is the there is an overview of our Test Universe software. Starting from this new test document, you can create a new test document, or you can use the BTL from our protection testing library after downloaded from the customer portal. Just you have to register in our customer portal by your email and the CMC serial number, and then you can download any kind of protection testing template from our website. Then you have to install it, and also you can reach it from our protection testing library. For example, if you need ABB RET 670, for example, you can check for this kind of relay, as you can see here, and you will find three kind of files. The first one is the OCC file, which is our protection testing template for this kind of protection relay. Second one is the X-ray file, which we use it to build up our PTT, and the third one, which is the PDF, and give you some instruction how to use this testing template and what is the setting required for testing, and many more instruction. So make sure to read this PTT instruction user manual before you are starting using the same PTT. Okay, so you can search for your SSC file using our BTL, or you can create a new test document. Okay, for a new test document, as you can see here, this is the name of the new test document. It can be saved and can be renamed from here. You can click Save As, and you can rename this one, so we can use it for training, for example. And I can save it on the desktop. So the name here will be changed, okay? And just follow our OMICRON OHM's law. Our OMICRON OHM's law, starting with O. O means the test object, which is the protection relay. So you have to double click the test object, and you have to enter the values of the CT, VT, and all the protection parameter setting. So just you can double click the device, and here, as you can see in the left, you have to enter. You don't have to, but this is good for good report to be printed out when you print your test report. So you can enter the name, the manufacturer, the device type, for example, ABB, and the device address, if main one, or FB, FM, FBSM, which means first the protection first main or second main, and many more. And the serial number also to be printed out in your test report. Any additional information like substation name also and the address can be entered, and the bay name and the bay address can be entered, or any additional information like the engineer, testing engineer, and many more here to be printed out in your test report. And starting from the important values here, so you have to select what number of phases you are used, and you are used for protection. So this too is used for a railway protection application, because in the railway protection you use only two phase for protection, but for normal cases and for normal substation you will have to select three phase, and you have to enter also the nominal frequency. As you can see here, 60 Hz or 50 Hz depends on the nominal frequency. And regarding the VT, you have to enter the VT ratio. Here is the primary, which is 110 kV over 115 voltage. You can change it. For example, you can make it 132 kV, and the secondary will be 115 voltage as a line to line, and the line to neutral, it will be automatically adapted if you are changing the primary values. So, for example, if you change the secondary voltage to be 120, so the line to neutral, it will be adapted to 69.28 automatically. Okay, all of this if you are starting from scratch, and I will show you also how to use the BTL. Okay. Now we are talking if you create a new test document from scratch with a blank sheet of paper, and you will build up your own test file. And here also you have to enter the CT ratio. For example, we have 600 0.6 over 1. So now 600 ampere primary, and the 1 ampere is secondary. And also, if you have a residual voltage transformer or a residual current transformer in the neutral side, you have to enter these values as well. Otherwise, you have to untick this value, so it will be not shown and it will be not used in the test module. And in the right, we have some other setting which can be taken from the relay manual. For the dropout time, we use it as a default 20 millisecond. And here is the limit of the voltage, and the current maximum values can be injected by the CMC. So the default values is 200 voltage line to line, and also the maximum value of current is 64 ampere. And make sure to check the relay user manual to check the relay withstand how much current and how much voltage for the analog card, for the analog channel card. Okay. Then we have also our overload detection sensitivity. We have different options here to detect the overload for the current channels. As you can see here, we have the high, which can be used for the digital and the numerical protection relays, which can detect the overload after 50 milliseconds. This is the fastest one. And we have a low, which can be used with electromechanical and the high burden protection relay, which can detect the overload by 200 milliseconds. And you can customize and put the value here based on the relay user manual. And the off is not recommended, because if you make it off, it will not detect any overload. Even if you have open circuit in the current channel or anything, you will not have any alarm or any notification that notify you we have overload here. So the off option is not recommended. Just if you have a numerical relay, you have to select the high. If you have electromechanical, you have to select low. We have also the debounce and the deglitch filters, and this vectors is specially designed for the electromechanical relay. If you have any shuttering for the electromechanical binary output of the protection relay, it can you can adjust the debounce and the deglitch filter to allow the CMC to precise detect the status of the relay binary output if you have any shuttering of the electromechanical relay. If you are using and if you are testing a numerical relay, just keep it as a default values. It's not important in that case. In case if you need any more information about any parameters here, just press the help button, and it will give you all kind of parameters and the meaning of each parameter. As you can see here, it will give you the definitions and how to detect. As example here, for the overload detection sensitivity, the high equals 50 milliseconds, the low equals 200 milliseconds, and the custom you can enter the overload sensitivity time based on the relay user manual. And the off, it will turn off the overload detection sensitivity, and it's not recommended at all. And for any and here is the debounce and the deglitch filter of the electromechanical relay. Just you enter here the CT and the VT and the nominal frequency and the information you need to be printed out in your test report, and then you can click OK. So this is the first part of our OMICRON Ohm's law, which is the O, means the test object, the protection relay parameters. The second one is the H, which stands for the hardware configuration. Now you have to identify how many channel of current, how many channel of voltage, what kind of binary input you are using for this for testing this kind of protection relay. So starting from here, you have to select the test set used. For example, I have no test set for now, but I will select the 356. After that, you have to identify how many channel of voltage you need, how many channel of current you need. Okay, so for example, I will keep it 4 channel of voltage and 6 channel of current. And here, if you press this configure button, it will show you how to adapt and how to do the wiring of the voltage and the current. So for example, 4 channel of voltage, it will connect the 3 channel of voltage for the line, and the 4th one for the bus bar voltage for synchro check and special kind of application. And here also you have to identify how many channel of current you need. If you choose the 6 channel mode, so the current output A will inject the 3 phase, and the current output B will inject the other 3 phase. So if you are online, it will give you some possibilities here to make parallel connection for the 3 phase mode and the single phase mode. So if you are choosing the 3 phase mode up to 64 amp, you have to do the parallel wiring between the red and red for current output A, and same for Y and B and the neutral. So you will have at the final, you will have 3 channel of current using the jump ring, the current output A and B, so you can inject up to 64 amp. And here is the fan mode, as we explained in our presentation, which prefer to be automatic, and it will be adapted automatically depends on the overheating and the temperature, the internal temperature of the CMC. So you can keep it as a default thing. And here is the sampled values in case of you need to simulate a sampled value streams in voltage and current to the digital protection relay. In case of you are working in a digital substation or a hybrid substation, you can simulate some sampled value streams instead of the analog voltage and the current measurement or injection. And here also some amplifier to be used to, if you are using some amplifier or low-level outputs for a special kind of protection application using the Rogowski coil or low-power instrument transformer, you can use it here as well. Then the second tab is the analog output. And as you can see here, we have 4 channel of voltage, which is connected by the X cross here. So VL1 is connected to channel number 1, VL2 is 2, VL3 is connected to number 3, and the V2-1, which is the reference for the bus power, it can be connected to the channel number 4 for a synchro check application. And this display name can be renamed. So for example, I can use this one to be V red phase, this one to be VY phase, V blue, and this one will be voltage for the bus bar voltage. So this display name, you are allowed to change the display name to be easy for you to understand what this kind of analog channel. And here also you can specify the connection terminal, because if you are customized and build up your own test plan, you can mention the connection terminal, so it will be easy for you and any of your colleagues. So you can add here the TB number like X1 number 1. So anyone will see this file, so he will connect the red phase voltage to X1 number 1, or the test switch TS1 number 1 or TS1 number 3, and many more. So it's better to name the connection terminal to be easy for you and any of your colleagues. And here also the current, as you can see here, we have current output A, we have current output B, because we choose the 6-channel mode. So this current output A is connected to IL1, IL2, IL3, as you can see here, and current output B is connected to the other 3 currents. So now we have 6 current connected to current output A and current output B. Then the third tab, which is the binary and the analog inputs. Now this binary or multifunctional inputs can be used as a binary, as a wet or dry, and also can be used as voltage measurement. If you have the ELT-1 option, you can specify this one to measure the voltage, or measure the voltage directly up to 300 voltage, or measure the current using our accessory C-probe 1 current clamp to detect the current measurement. Or it can be used as a counter for energy meter calibration. If you have a binary output of the energy meter, can be connected directly to the input, and you have to configure this one in that case to be a counter. So we will keep it as a binary. So we have 2 options here, as we mentioned in the presentation. We have a potential free and we have a potential voltage, which means dry and wet. So if you are using a wet contact, you have here to specify the nominal voltage of the DC circuit, of the tripping circuit. For example, if this contact is used in the tripping circuit or circuit breaker, and this tripping circuit is 125 voltage DC, you have here to specify this nominal range, and it will detect the threshold that is 20% from the nominal value automatically. So if I have like 110 or 100 voltage DC, it will change the threshold automatically to 70 volts. So once the voltage drop across this contact exceeds the 70 volts, it will detect as a binary input close or open. Okay, is that clear? If you are using the spare wired, you have to tick this one, which means this potential free, and it will be dry contact as a spare contact or spare wired contact. Okay. So this is for the binary and the analog inputs. For the binary outputs, you have 8 binary outputs. The 4th is coming from the front view, and the other 4 is coming from the external interface from the rear side of the CMC. So if you need to simulate any kind of event like CB close, CB open, which is 52A, 52B, or CB manual close command for switch on fault, BTM CB trip, for example. So you can connect the binary output of the CMC to the protection relay binary input to simulate this kind of events, and to use it in your protection, like the circuit breaker initiation, circuit breaker fail initiation, and many more usage. Then we have the DC analog inputs for the transducer measurement. If you have the ELT-1 option, it will allows you to measure the voltage from 0 to 10 voltage and the current from 0 to 20 milliamp. And the last but not least, which is the time source tab. Here you can identify and specify the connection of the GPS to your CMC. For example, in end-to-end testing, you have 2 CMC, each one in local substation and the other one in the remote substation. And you are using the CMGPS 588 as a time source for synchronization. So it will be connected using the power over Ethernet. So it will get the power supply from the power over Ethernet port, and it will communicate to the CMC in the same time using the same cable. And we have many more different modes to connect to your CMC. As you can see here, if you have a BTB master from the substation, it can be connected to your CMC, and it will get the time source directly by connecting to the Ethernet 2. If you need any help here, just you can click the help, and it will give you all the time source tab configuration option, and it will explain how to use each one and how to be adjusted to your protection application. The same for each tab. You can press the help button and it will give you all the meaning of each parameters. Now we finished the second part, which is H, stands for the hardware configuration. The third part of our OMICRON Ohm's law is the M, stands for the test modules. So now I have to insert some modules to test the different functions available inside our protection relay.